Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a last numerical which is based on a structures realization of LTI discrete time system in Z domain. Now this is our last numerical, and in this we are going to solve a cascade and parallel form. So first of all, we'll see the question. Now, problem number 6. What is mentioned? Obtain a cascade and parallel relation of LTI system with a transfer function is given h of z 1 plus 5 by 6 z inverse upon 1 minus half z inverse minus half z to the power minus 2. Now we'll go for solution. So the last question, h of z is 1 plus 5 by 6 z inverse, and in denominator we have 1 minus half z inverse minus half z raised to minus 2. Now first of all, we will calculate a cascade form. Well, in cascade form, what we want to factorize, or we need to factorize numerator as well as denominator. Basically, in numerator we already have one factor, or we can say one term, but in denominator we have an equation. So we will factorize the denominator. Now, what you will get? If you factorize this part, then my answer would be 1 minus z inverse, and in second bracket we have 1 plus half z inverse. Now, how to get this answer, or how to obtain these factors? I'll tell you. Basically, we have half at the end, or the lowest power of z is having coefficient half. Now, or you can say constant half. Basically, if we multiply 1 with a half, answer would be half. But the middle term is always addition of these two. So a minus 1 plus half result gives us a minus half, and minus 1 into plus half, answer is minus half. That's why I have got these factors. I'll mark this is my equation number 1. Reason is we required this equation in parallel form. Now we will proceed. Basically, in cascade form, what we want a product of two transfer functions. So let's say my first transfer function is 1 plus 5 by 6 z inverse, and another one is 1 minus z inverse, which is in denominator. This is my first transfer function, and the second one is, here we don't have anything, so we'll replace it by 1, and in denominator we will have 1 upon 1 plus half of z inverse, and this is nothing but, I'll consider, it is nothing but the product of two transfer function. The first h1 of z is nothing 1 plus 5 by 6 z inverse upon 1 minus z inverse, and the second h2 of z transfer function is 1 upon 1 plus half of z inverse. Now basically, as I told you, we will always prefer a direct form 2 structure in while designing a cascade as well as a parallel form. Now we will design h1 of z and h2 of z by taking help of direct form 2, and I'll connect both this transformation one after one, or you can say in series, or you can say in cascade. So my h1 of z is 1 plus 5 by 6 z inverse, and 1 upon z inverse is in denominator. Now just compare this h1 of z with the standard format of transfer function. What you will get? This will gives us a value of b0, and this 5 by 6 gives us a value of b1. And my a1 value is minus 1. Here also we will compare this h2 of z equation with a standard transfer function. So we will get b0 value is 1, and after comparing denominator, what we will get? a1 value is only half. Now we will draw a 2 DF1 structure. The first one is for h1 of z and another is for h2 of z. This is my h1 of z and next part is my h2 of z, and both are connected in series or in cascade. Now in DF2 structure, the right hand side part is always for B or constant B and left hand side part is for A. Now, so first buffer gives us a value of B0 value and the B0 value is 1. So I'm going to write here inside this block. Now B1 value is 5 by 6. That will be written over here. Next one is A1. Here A1 is minus 1 and we know that we will always write or we will always multiply minus sign with A1. So minus of minus 1 is plus 1. So this is my plus 1. Now we'll move on to h2 of z. Basically here B0 value is 1. So I'll write it over here inside this buffer. And my A1 value is half. So after multiplying minus sign with A1, what you will get? Minus half. And this is nothing but my cascade form. Now in cascade form, always two functions are connected in series, whereas in parallel form, always two functions are connected in parallel, that is 1 by 1. Now we'll move on to parallel form. So parallel form. From equation number 1, we have already calculated this value. We have already factorized the denominator also. Now in parallel form, we want two different functions, but they must be added with each other. So how to achieve addition? By just performing a partial fraction. So here we have two poles, which means we will use two different variables. Let's say A and B are the two different variables, and I'm going to write in denominator of A will place 1 minus z inverse, and in denominator of B we'll place 1 plus half of z inverse, and I'll represent this is my equation number 2. Now we'll just multiply left hand side denominator on right hand side. Now we are going to calculate or we are going to obtain the values of A and B by just substituting the different values of Z inverse. Now we are going to replace the value of Z inverse by which value? Look at here. If we want to calculate A, then whole B value must be replaced by 0. All the product with B will be replaced by 0, which means if I place Z inverse equals to 1, then 1 minus 1 will get cancelled and this whole product will also gives us value 0. So you will get automatically value of A. Now, so we will substitute Z inverse equals to 1. So this Z, all this Z will be replaced by 1. But in the last block, as the Z is replaced by 1, 1 minus 1 becomes 0 and 0 into B is 0. So I will replace all this product by 0. Now look at here. 5 by 6 plus 1. After cross multiplying this 6, what you will get? The total outcome on left hand side is 11 by 6. And look at here on right hand side. After cross multiplying all this value, you will get a 3 by 2. Now shift this 3 by 2 on left hand side. So this will be a 2 by 3 multiplied with 11 by 6. Now this 6 can be divided by 2. The answer is 3 and total overall answer of A is 11 by 9. Now similarly we will calculate the value of B. Now the next part is we want to calculate a value of B or value for B. Now if I replace this whole Z inverse by minus 2, then this half, that is 0.5 into minus 2, answer is minus 1. So this plus sign is also replaced by minus 1, and 1 minus 1 is 0. Automatically this whole A into 1 plus half of Z inverse replaced by 0. So I'm going to substitute Z inverse is by minus 2. Now next, so all this Z inverse will be replaced by minus 2. I have replaced A plus half of 1 plus half of Z inverse, replaced by 0. Now look at here, we can divide this 6 by 2, answer is 3, and we know that here the minus sign is multiplied with the plus, so you will get 1 minus 5 by 3 on the left hand side. And on right hand side, what do you get? Minus into minus, answer is plus, so 1 plus 2 is 3. Now just cross multiply this value, so 3 into 1 is 3, and 3 minus 5 is minus 2, so what you will get? Minus 2 by 3. And when I shift this 3 on the left hand side, then my B result is, now substitute the value of A and B in equation number 2. So after substituting the value of A and B in equation number 2, I have got this result. Now as I told you, h1 of z in parallel format, what we want? The addition of two transfer functions. So let's say 11 by 9 upon 1 minus z inverse is my first h1 of z, and the second part is my h2 of z. Now just compare this h1 of z with the standard form of transfer function. What you can see? Here my b0 value is 11 by 9 and my a1 value is minus 1. Whereas in h2 of z, my b0 value is minus 2 by 9 and my a1 value is half. Now what I'm going to do? As I told you, we will always prefer a direct form 2 while designing cascade form and a parallel form. So I will use a direct form 2 for h1 of z and for h2 of z. Now look at here, this first upper block gives us h1 of z value and second was h2 of z value. Now we know that this is the place of b value and here b0 value is 11 by 9. Now here this buffer gives us a value of a1 and here we will always multiply minus sign with a1, so minus into minus 1 gives us a plus 1. Now on next part, in h2 of z, this b0 value is minus 2 by 9, so I will write minus 2 by 9 over here, and my a1 is always multiplied by minus sign, so this plus half is replaced by minus half. So I'm writing outside this block by connecting one wire, and at the end both the values will be added, so I'll use a summation. So this is all about a cascade form and a parallel form. The first three videos or first three numericals are based on df1 and df2, and next three videos are totally based on cascade and parallel. Stay tuned with Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.